Hello everyone. As you can see, we've made a major progress with our test bench design for high power motors up to 30 kilowatt. And you can see we've completed the panel, the electrical part, an AC part and supply, which is in the middle. We've done the major wirings for the high power. You can see some thick wires going here from the motor, from the controllers. And obviously we've tested some of our controllers at a very harsh condition with the load that you might see in the next videos. And it's pretty much ready. I mean, it's working very well and we're very happy with the result. So in this video, we're gonna show you more about the assembly of it, putting all these components together, the body, the handles, the motor and the brake. And then later on the next videos, we're gonna go deeper on the electronics of it. So as this whole thing is a pretty sophisticated setup and assembly, we might not talk about some details of some parts, or we might forget about them. But if you have any questions or any idea about any part, just put a comment for us, ask it, and we're gonna either make a video about it or we're gonna answer your questions. Also about the testing of the motors, about the testing of the variation of the load or whatever. Just feel free to ask the questions and don't forget to subscribe to our channel. Thank you so much.
Hello everybody. So today we have our T-slot plates, this heavy one, the brackets, the mounting plates, aluminium bars, some screws, nuts and tools, some wheels, stands, and we are going to start the mechanical assembly of the test bench. First of all, let's mount the wheels and stands from the bottom part of this basement. We have the holes here for the wheels and for the stands. Let's do this. I also use the Loctite to be sure that the screws will not be untightened during the test bench working process. The washers. So the wheels are already installed, as you see. I can move the plate and the wheels, tighten the bolts, and now it's the turn of the stands. This is M12 ones, and we need some washers, so I bought them additionally. So now we have already done with the stands and with the wheels, and we need to mount these bars. Those holes here are designed exactly to mount the bars. So we need to make a thread here, M8, to mount the bars on the corners of the plate. Okay, about the threads. Luckily we have the tool set here. Like for M8, we'll use 3 thread maker stubs. Just upgraded my tool by adding some thermoseal tubes on the handles. Otherwise, like, they were quite sharp to use, like, without the gloves. And So now we have the plate assembled with the wheels, leveling elements, and the next steps are to mount the brake, the motor. Today we're going to start testing from the smaller motor, the clamp to connect the general shaft to the motor, mounting brackets, those massive that we already showed before, the mounting plate for the motor, the mounting plate for the brake, shaft, encoder, the hollow shaft design, some key elements for the shaft, and also the mounting plate for the encoder, which I need to fix a little bit to drill some holes to mount the encoder brackets here. Let's start. To mount the brake with this transmitting plate to the bracket, we use M6 bolts and 4 holes. So this is assembled the brake, mounting plate and the bracket. So here is the connection with the T-slot nuts. Let's put it on the plate. The only thing I forgot is the mounting plate for the encoder. So the plate should be mounted here, encoder should be mounted here. And also those tiny brackets, like flexible brackets for the encoder, should be screwed on this mounting transmitting plate. So I need to mount it, to draw the holes, and then unmount, drill, make some threads, and mount again. For easier handling, I will fix the mounting plate on the wooden plate by like these screws. This is temporary solution just to drill on my drilling press. So I did some mounting holes here for the encoder, and now we finally are ready to mount all this together. The encoder to the mounting plate, bracket, the shaft, all these things. Also we exchanged the length of the screws since we are adding this mounting plate 5 mm thickness. So what we have now is the brake mounted on the bracket with the mounting plate of the encoder itself, and the shaft. So we need to tighten the inner clamping of encoder and also mount the motor here. So this is the motor we're going to attach. It has the shaft 9 millimeters and we have the shaft 15, so that the clamping is used here to connect them. Also another mounting plate designed to be able to mount the motor on the bracket. I also prefer to mount the coupling before I will mount the motor to the bracket, because this hidden screw here will be near impossible to tighten. So this is the connected and assembled couple of motor and brake with encoder in between of them, and the most tricky part here is like how to align the motor with the brake, just to avoid the shaft misalignment between them. So here we use a special coupling which helps us to avoid some tiny disalignments. But also you can find a special device for precise alignment between the shafts. Here we use something more simple, the level, which has near the straight surface here on one side, and also those slots have the straight surface, so I just tie them to one side that they are aligned with these slots. And then after assembly, when we will launch the test bench, we will also try and then check if the shaft is aligned enough. I will also check by the caliper the dimension between the sides of the brackets to be sure that they like parallel one to another. Actually, all these things play a huge role. The precision of the machining of the brackets, of the basement, also of the mounting plates. So the alignment of those two elements is a hard task, is something significant. So here we have 91.69, and here we have something 91.45. 69, 71. Okay, so now the setup is assembled. The motor, the small one we are using today, but actually the test bench designed like that to be able to exchange the motors. So we have the bigger and the biggest. So we have like a bench of motors to test on this test bench. The coupling between them, this is the flexible, this is encoder, the shaft, mounting plate of the encoder, the bracket of the brake, mounting plate of the brake itself with the fan. So everything mounted on the T-slot plate here, and the only thing we need is the beams, the aluminum structure here to be able to mount the electrical cabinet and the panels, the covers, the control panel, everything like that. But this is the core of the test bench. These are the main components of the test bench. The only thing I need to add is that we now are missing the middle component, which is the torque sensor. We are waiting for that, but we need this test bench for working on it. I mean, this is not for fun to design this difficult structure, but we need to test the controllers and the motors, so that we decided to start without the torque sensor, since it is like additional measurement. So mostly we need to create the torque here, for which we use this brake. So the beams, the aluminum bars that we are going to use is the main structure for the electronics and electrical cabinet, the control panel, all the things included, controllers, is that. So I created the treads here, M8 in the inner hollow parts here. Actually, these beams are designed specially to be able to be mounted also on these holes. And I'm going to now install it. To mount these intermediate beams, we use these hidden brackets. What actually will be just a part of the mounting of the intermediate level with electrical cabinet, because we are using the bended parts, like metal sheet bending. This will create additional strength in this level. One important thing that I'm always missing is that we need to put the inner nuts here before we mount actually the beams. So 3 nuts aside. This is for the electrical cabinet mounting plate, so we definitely need them. observation of what we're done today. Yesterday I've assembled the test rig, structure, main components, the motor with the brake encoder, and today I spent to connect everything together. I like the current controller for the brake. This is the connection for the encoder, the power connection for the controllers, potentiometer to control the torque of the brake wires, plus 34 volts for the brake. That's it. Also have here the connection of the motor, but first we need to check the connection of the controllers and then the identify wires of the motor also.
So with load is better.
Yeah, because it's just...
But now you didn't height super high.
Just two of them.